Hi, everyone. This is Matt Woods from the Academic Success Center, and I'm coming to you 6 years in the future from my other YouTube videos on the math placement test, because we've changed it within the last 6 years, and I wanted to just go over a couple extra topics that we didn't hammer quite as hard as we should have before. Better late than never, I suppose. So first one that we're going to do today is rationalization. So rationalization occurs, well, needs to be done, I should say, when you have an incorrect fraction. Just as a heads up, you might notice my setup is a little bit different from the other videos. I'm using the whiteboard function of Zoom with my Wacom tablet, and I'm recording off my laptop instead of one of the document cameras here on campus. So incorrect fractions have one of three things in denominator. They could have a second denominator. They could have a radical. Or they have an imaginary number. Now, we've toned down the amount of imaginary numbers that we use on the placement, so these are the only ones we're going to focus on. So what does the second denominator look like? Let's start with that. Well, it could come in one of two flavors. You could have fraction over fraction, in which case you copy, change, flip. So I talked about this way back in one of those early videos that I did with dividing fractions. But real quick, if you have something like this, 1 over x, here's my big bar, so that's where I put up my divide sign. And then I flip, or let me rewrite it first. Now I can copy, change, flip. Copy the first one, change the multiplication, flip the second. Always throw your whole numbers over 1, multiply across the tops. X over 1, which is just x. The other ways you have expressions. Something like this, z over z plus 8 over y. In this case, because I have an expression down here with here's my second denominator, I'm going to want to get rid of this y down here. So I'm going to multiply all terms by the second denominator. So I'm going to multiply this one here by y, but I'm also going to multiply this z here by y, and this z here by y. So I get zy over zy, z not a 7, plus 8y over y. These cancel out, so I'm just left with zy over zy plus 8. So that's all there is to these. You have to remember to multiply every term. You're not just multiplying this one part of the expression here and the numerator. You have to multiply every term in the expression. Otherwise, it's not going to come out correctly. Okay. The other condition, remember, is with a radical. So that's something like this, 5 over the square root of 10x. In this case, I'm going to multiply top and bottom by the radical. Multiply top and bottom by radical 10x. The top is just going to sandwich together. It's 5 radical 10x. So we'll make a note here, sandwich together. Over. Now what's going to happen here is these multiply together to give me the square root of 100x squared. Well, that's a perfect square. The square root of 100 is 10. The square root of x squared is x. So notice that the radical sign basically just goes away. Now the last thing I do is I try to reduce, if necessary. 5 and 10 reduce each other. So 5 to 5, these 5 can go into both. So that's going to leave this as 1 or just radical 10x up on the top. Over 10 divided by 5 is 2. Now I can't reduce further. I can't reduce the radical 10x and the 2x. The reason for that is that only a radical can change another radical. That's crazy important. You've got to remember this. That's basically all there is to rationalization. I hope you learned something from this, and I'll see you in another video. Bye-bye.